Alright, hi there guys, my name is Wilfred and I'm a senior math tutor, and today I'll be covering 10 questions related to functions, algebra, and calculus. So a little bit backstory upon myself. I graduated from McMaster with a major in biochemistry and a minor in mathematics. And if you have any other issues with math or chemistry or calculus, please submit them to OneClass, your questions, and we'll get them done as soon as possible. So other than that, let's just jump right into it. Okay, so the first question reads, what is the solution to the system of linear equations? And they give us two linear equations here. 2x plus y equals 1, and 3x minus y equals negative 6. So another way that we can rephrase this question about finding solutions to a system of linear equations is to find the point of intersection between these two line equations, okay? So that's an alternative way of writing this question. And so one of the solutions and one of the ways that we can solve this system of linear equations is by graphing these two lines and identifying visually where they intersect. So there are two other methods that we can use to solve the system of linear equations, and the junior tutor outlines them here. There's a substitution solution and there's an elimination solution. So I'll run through both of them today. Okay, so for the substitution solution, we basically want to sub one of the linear equations into another. And how we're going to do that is for one of the linear equations, we're going to isolate for the variable y or x. Really depends on how you feel, but we're going to isolate for the variable y. Okay, so let's first do substitution here. Substitution. Okay. So the first thing that we want to do is we want to define which equation is which. Okay, so if we write out our equations, 2x plus y equals 1, and 3x minus y equals negative 6. I'm going to label this equation 1 and equation 2, so there's no confusion here, okay? So for equation 1, we're going to transform it by isolating for y. So we're going to move this 2x to the right-hand side. To do that, we're going to subtract both sides by negative 2x, and we get this. So y equals 1 minus 2x, and we're going to call this equation 3, okay? So now, we're going to sub equation 3 into equation 2, okay? And what I mean by sub is that we're going to take y, which equals 1 minus 2x, and sub it into 3x minus y equals negative 6. And particularly, I'm going to sub in y into this y here, right? So now we have 3x minus 1 minus 2x equals negative 6. And if I were to simplify and isolate for x, this is what we will get. We'll get 5x equals negative 5. Okay? And now that we have isolated for x, we can just divide both sides by 5, and we get x equals negative 1. So now we have found the x value for the solution for our system of linear equations. Now all we need to do is sub this back into 3, for example, and we'll get our y value. So we sub it back into 3, we get 1 minus 2 times negative 1, and we get 1 minus 3. Okay? So therefore, the solution is negative 1 and 3. Okay? So that is the first technique that we are using, substitution. And basically, this is the computational method of finding the point of intersection between these two line equations. Okay, so now let's talk about elimination. Okay. All right. So elimination is kind of different in the way that we are going to basically subtract these two linear equations from each other. And what I mean by that is that we're going to, first of all, we're going to write them out like this. And we're going to treat this like a subtraction or addition, depending on what we want, okay? But the main thing that we want to do is we want to eliminate one of these variables in both of these linear equations, okay? So you see here that if we were to add these two linear equations together, so we add the left-hand side together and the right-hand side together, we would get rid of our y variable. So if we were to add both sides, we would get 5x plus minus, so y, positive y minus y is 0, and then we would have negative 6 plus 1, which is negative 5. Okay? So we see here where the term elimination comes in, right? So for elimination, we want to get rid of one of the variables, okay? So by getting rid of one of the variables, we can isolate for the other one and solve for it, okay? And in this example, it's very easy for us to eliminate the variable, but sometimes you have to multiply one of your linear equations by a constant to be able to eliminate that variable. For example, if, let me write out an example real quick. If we had, instead of 2x plus y, we had 2x plus 2y equals 1, and we had 3x minus y equals negative 6. If we were to add these two linear equations together, we wouldn't be able to eliminate one of the variables. So therefore, we would have to multiply this by 2 first, okay? So we have to multiply this by 2, we would get 2x plus 2y equal 1 for our first linear equation. If we multiply both the left-hand side and the right-hand side by 2, we get 6x minus 2y minus 12. And here, in this example, we can now add these two linear equations together. Sometimes you have to subtract, sometimes you have to add, sometimes you have to multiply by a constant, sometimes you have to divide by a constant. And really, the technique that you use really is dictated by how you want to eliminate that variable, okay? In another case, if I wanted to eliminate the x variable, then I would have to multiply this first one by 3 and the second one by 2 to get both sides to be 6x, right? But here I recognized that the y variable is easily eliminated, so that's what the one that I want to eliminate, okay? So whenever using the elimination technique, always recognize and identify which variable is easier to eliminate. Is it the x variable or the y variable? And by doing that, you save yourself a huge headache of trying to multiply or divide by constants, okay? So going back to our question here, we have now eliminated the y variable, so now we have 5x equals negative 5. Right? So now if we isolate for x, we get x equals negative 1. Okay? So now we found our x value of our solution, and now we just have to plug it back into one of our linear equations. So let's do this. And plug x, or plug 1 into 2x plus y equals 1, and we get negative 2. Sorry. Let me write 2 times negative 1 plus y equals 1. If we isolate for y, we get y equals 3. And therefore, solution is negative 1 and 3. Okay, so the last thing that I want to point out after all of this is that there are 3 possible solutions to a system of linear equations. So the first possible solution is that there's one point of intersection, right? If we were to think about it in the beginning when I said that an alternative way of explaining this question is to say that find the points of intersection between these two lines, right? So the first option is what we solved here. There's one point of intersection, right? The second type of solution is that there is no point of intersection. And this is where the lines are parallel to each other and that they never touch each other at all, okay? What I mean by parallel to each other is that that they both have the same sign of a slope, so they either both have a positive slope or a negative slope, and also their slopes are also the same, but the y-intercept is different. Okay. And finally, the third type of answer is that there's infinite point of intersection, and this is where both lines in the system are the same. So they're essentially the same lines, so they intersect infinitely. Okay, and I guess another point that I will leave off with is that the system of linear equations does not need to be just 2. It could be 3, it could be 4, it could be 5. And when you increase the numbers, then you're trying to find a point of intersection between all those lines. Okay, so that's the last thing I want to leave off on. And other than that, this solution is correct. Sorry, give me a second. My audio is not working still. Hello? Can you guys hear me now? Hello? 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 Okay. Can you guys hear me now? I believe you guys can. Okay. So I think my mic was functioning for the whole question. So I'll quickly run through the question again. So the question reads, what is the solution to the system of linear equations? And the linear equations here are 2x plus y equals 1 and 3x minus y equals negative 6. Okay, so how I found the solution to the system of linear equations is by what the junior tutor suggested to us. So there's two different techniques. One is substitution and one is elimination. So for the substitution technique, you basically want to isolate for one of the variables within your linear equations and sub it into the other linear equation. So here, first of all, we need to label the linear equations within our system to be clear on which one we're isolating for. So you can choose either linear equation to isolate for, but I chose equation number 1. I isolated for variable y. So once I isolated for variable y, I took this this new equation, which is number 3, and subbed it into our equation 2. So I took the y and I plugged it into negative y here, and I isolated for x. And by isolating for x, I found the x value of our solution, which is negative 1. So after that, I plugged negative 1 back into one of the linear equations to find the value of y. And by doing so, I found the value of y to be equal to 3, and therefore the solution to this linear equation is negative 1 and 3. And I previously mentioned before that alternative way of listing or writing this question is to find a point of intersection between these two lines. Okay? So now that we're talking about elimination, this technique is a little bit different in where you're trying to get rid of one of the variables by adding or subtracting the linear equations together. In this case, in our example here, I added both of our linear equations together. So what I mean by adding is I'm not trying to add them in the conventional manner. I'm basically adding together the left-hand side and adding together the right-hand side. And by doing so, I was able to get rid of the y variable and isolate for the x. So I found the x value of our solution, and then I plugged it back into one of our linear equations to find the y value of our solution. And then here I described that in our actual example, our specific example, I only had to add together the linear equations. However, this is not always the case because sometimes you're given two linear equations which the variables are not so easily eliminated. So that means that you'll have to use different techniques like multiplying or dividing your linear equations by a constant, or subtracting your two linear equations together, or a combination of all those factors here. And I use this example to show it, right? So if our linear equations were 2x plus 2y equals 1 and 3x minus y equals negative 6, I would have to multiply our second equation by 2 to be able to eliminate the y variable. And the final note that I touched on is that you can choose either x or y to eliminate, but I would say that a tip is that you want to identify which variable is easier to eliminate. Is it the y variable or the x variable? In our specific example, it was a y variable that was easy to eliminate, so I did that instead. Okay, so basically after that, the solution is correct and we can move on, so good job. Cool. All right.